Right, integrals of exponential functions. The integral of e to the u is just the same as the derivative, right? The derivative of e to the u is e to the u. Integral is e to the u plus c. Okay, so simple enough, except a lot of u substitution. All right, so because remember, when you do the derivative, you've got to do the derivative of the inside. So here, when you could do the integral, you have to use u substitution. U equals 3x plus 1, so du is 3 dx. dx is du over 3. So the integral of e to the u times du over 3 puts a 1/3 out in front. Okay, so integral of e to the u is e to the u, so you get 1/3 e to the u plus c. Alright, number 2, now we have 2 and 3. Okay, so number 2, we're going to let, again, u equal the exponent. That's your inside function. So du is negative 2x dx. dx is du over negative 2x. So when you integrate, you have 5x times e to the u times du over negative 2x. The x's cancel. Negative 5/2 comes out in front. The integral of e to the u is e to the u. So negative 5/2 e, I'm going to plug that back in to the negative x squared plus c, which makes me forget I didn't do it up here. This would be 1/3 e to the 3x plus 1 plus c. Alright, finally on number 3, cosine of x times e to the sine x. Again, if you let u equal sine x, the derivative is cosine of x, that's part of it. Okay, so u equals sine of x, du is cosine of x dx, so dx is du over cosine of x. So cosine of x times e to the u times du over cosine of x, those cancel. The integral of e to the u is e to the u. So you have e to the sine of x plus c. And once again, you can always take the derivative of this to make sure you get what you started with. Okay, you can always check your work here. So, find the equation of the tangent line to the graph of y equals e to the 12x at the point 0, 1. This is going back and doing applications now involving e's. Alright, so here y equals e to the 12x, so equation of the tangent line, I need a slope. Slope is the derivative, so y prime equals 12e to the 12x. At the point x equals 0, so 12e to the 0, e to the 0 is 1, so that slope is 12. So the equation of the tangent line, 0, 1, that means 1 is your y-intercept. So y equals 12x plus 1. That's all. Okay? The second one requires a little more thought though. Find the particular solution that satisfies the initial conditions. You have f double prime of x equals 1/2 e to the x plus e to the negative x. Now, you have f of 0 equals 11, f prime of 0 equals 5. So, f prime will be the integral of f double prime. 1/2 I'm just going to move out in front. You have e to the x plus e to the negative x dx. Okay, so you have 1/2. Now, integral of e to the x is e to the x, and then the integral of e to the negative x. Now, if you think about that, if you let u equal negative x, du is negative dx, so negative du equals dx, that just adds a negative in there. Okay, it'll be negative e to the u, which is e to the u. So it becomes negative e to the negative x plus c. So you have 1/2 e to the x minus 1/2 e to the negative x plus c, and this is f prime. You know that f prime of 0 equals 5. So 5 equals 1/2 e to the 0 is just 1 minus 1/2 e to the negative 0 is just 1 so 1/2 plus c. Therefore, you get c equals 5. So f prime of x equals 1/2 e to the x minus 1/2 e to the negative x plus 5. You also have f of 0 equals 11. So we have to integrate 1/2 e to the x minus 1/2 e to the negative x plus 5. We are integrating that. Integral of 1/2 e to the x is 1/2 e to the x. Remember what the first one did of e to the x, so that's just going to be a negative, so that now becomes positive 1/2 e to the negative x plus 5x plus c. F of 0 equals 11, so 11 equals 1/2 e to the 0 plus 1/2 e to the 0 plus 5 times 0 plus c. E to the 0 is 1, so 1/2 plus 1/2 is 1, plus c equals 11. So c equals 10. Okay, so you get f of x equals 1/2 e to the x plus 1/2 e to the negative x plus 5x plus 10. Okay, and that is it for integrals of exponential functions.